So good morning, everyone. So this is the first time you probably noticed that a cloud computing company come to the mobile MWC. The reason is very simple. With the mobility available, with the connectivity available, what's the next? And this question has been existing and has been asked for many years. And today, with the cloud computing available, and with some of the reference cases available, I'm going to bring an answer. The answer is smarter with the ET Brain. So we give the answer because we have our practice and the reference case in China. As you can see the footprint over the past 2 years. We started with something like the popular talent show in China 2 years ago. We successfully predict the final the season finale, the championship, and the ranking of all of the players in the finale. And after that, we introduced the ET Brain as official brand, and we deploy the solution in different verticals, including, as you can see, like the City Brain, which is the city management, in the Industry Brain, which is essentially a smart manufacturing. We use the brain together and coupled with the existing data, and we develop on-demand dynamic control of the process parameters on the fly, rather than predefined fixed template. And the result I will show you later on, okay? And the latest one is 2 months ago. This January this year, we announced that in Malaysia, Kuala Lumpur, and the City Brain, we are going to help them to develop a dynamic system to do preemptive traffic signal adjustment to reduce the traffic congestion. So all of this follow a suit, which is we go vertical, first of all, where the data sits, where the intelligence are hibernating, and then we want to activate. We activate use the cloud computing. We activate with the AI technology. And we do a deep dive and unleash the hidden value of the data. So mobility, connectivity, and smarter algorithm and product deliver a smarter life. So convenience is not enough. Smartness is the next answer, next stage for everybody, including you and me. Okay. Now, why we do this is so essentially to follow the same idea. You have the sensors, you sense the situation, you have the real-time incoming streaming of the data, and then you need to digest on the fly, and then you need to turn the insights to actionable. With the action, you see the business impact. So without this closed loop, it's just a hand waving, a dream. A dream never comes true. But now with this, with the computing inside, with the algorithm, with all the connectivities available, ROT available, and this closed loop become reality. So the rest is just how you deploy this triangle, this closed loop to different scenarios, different verticals. So the idea, okay, why we call this brain rather than something different, a platform? Because exactly the idea is driven by an energy of our human brain. Because our human brain, human beings, our brain consists of 10 to the power of 10 neurons. It's a network. Again, it's a network. It's a connected network. And the neurons are communicating with each other by doing the spikes, the electricity, electro signal, okay, like the EEG wave, the brain wave, okay, they communicate through this signal. Every second, okay, this 10 to the power of 10 neurons that communicate, they vibrate synchronization. So how do we do this? So why do we want to use the brain-alike neural network structure to do the ET Brain? Because, let me give you this example. Because it has a deep-rooted, deep origination from a paper published by Einstein, Albert Einstein, in 1905. In that year, he published 3 papers. One is a special relativity, and one of them is Brownian motion. The Brownian motion basically is talking about in a lattice, in a system, the particles, the pollen. In his paper, he was talking about the pollen, okay? So how does the particles synchronize and act as if they have a coordinated commander-in-chief? The system, the magnitude is 10 to the power of 20. 10 to the power of 20 particles acts as if synchronized by one commander-in-chief. This is Brownian motion. Okay, he come up with the idea as a mathematical tool, Brownian motion. And ever since his paper, and then there's a complete new, okay, research field called stochastic process. And likewise, our human brains, okay, all the neurons are talking to each other by doing the signal transformation. So similar to this the pollen system, pollen particles. So now imagine if somehow we observe all of our brain EEG wave signal, their activities, and what can we do with that data? And we can deduce and back reinforce the underneath mechanism and the critical path of the interaction between different neurons. Once you know the critical path, use the quantum topology, and then you can do a lot of things. How do you intervene or intercept the signal, or even magnify the signal transformation from one point to another point? Or how do you accelerate this transfer of the signal? So all these questions can be answered if somehow you found the critical path. Now, this sounds like a neurology research seminar. However, if you think about the analogy, okay, our human neural network versus the city network, which is the road network, intersection to intersection. And between the intersection, that's a traffic flow. There's bicycles, motorcycles, there's a human pedestrians, okay? It's a fixed neural network with dynamic flow. And likewise, our logistic network, our machine manufacturing production line, okay, from one procedure to another procedure in the process flow, okay, process manufacturing, the different posts, okay, different positions, they have to coordinate with each other in order to make sure the final product has a stable yield, stable quality. So all of this requires a fixed network and a dynamic interaction on this network. So once we find an abstraction of this structure, and then we can do the ET brain. So it doesn't matter it's traffic or transportation, logistics, or even weather conditions. Later on, I will show that. So this is a case where we, in the past 2 years, Yemin just alluded to moments ago, we deployed this city brain. We successfully reduced the traffic congestion. And I want to share this case in particular, because this case is really a life and death difference, because in China, in Hangzhou, we deploy the city brain and integrate with the traffic control system. We managed to cut down, reduce the travel time of ambulance by more than 50%, 50%. So this reduction of the travel time for ambulance is invaluable. It's beyond money. As you can see that every second cut in the ambulance travel time. In the old days, it requires all the drivers to yield the road to this ambulance for the ambulance to rush to the ER room. But what happens if there's a heavy traffic jam? There's no room for maneuver. The drivers couldn't do anything and sit on the driver's seat of the ambulance. But today with this, we can predict the arrival time to any intermediate intersection in advance and command and synchronize to the traffic signal control system and make sure that 10 seconds ahead of the estimated ETA, and it becomes a green signal and clear the traffic flow and create a free flow green wave for the ambulance. That cut down the travel time by 50%. So, and this system is a first of a kind. It requires a determination to integrate multiple systems, first of all. And second, it requires this quantum thinking. What if there's an intersection incident, somebody run against traffic signal and create an incident on the driving route of the ambulance? What can we do? All this answer has to be given, taken care of on the fly, and synchronized with the traffic signal system. And we managed to do that. So 50% reduction of ambulance. And the next case, for the industry brain, so it sounds like weird, because why do we, as a cloud computing company, why do we want to look at the machine, the traditional equipment, the